During the second chapter, we are going to investigate the field-oriented control algorithm in details using the previously learned physical background on PMSM motors. Firstly, an overview of the FOC algorithm is going to be presented, where we are going to shortly discuss the basic concept of the signal flow and main challenges. During the function block representation, we are going to mention the main coordinate transformations needed for FOC, as well as learn where the MATLAB Simulink developed software shall be embedded in order to implement an efficient code structure. Lastly, I am going to introduce several possibilities of practically used encoders for determining the precise pole flux angle of the rotor. In the C and D points, we are going to mathematically describe the so-called Clarke and Park coordinate transformations. The main goal here is to deduct a scalar equitation for both coordinate transformations that could be easily implemented to the function software. Finally, in the E and F points, we are going to investigate the proportional integral regulators in the FOC algorithm. To name them, we are going to have a short look to the speed and current controller, main purpose and working principle. During the next slide, further content will be presented regarding the second chapter. Let's continue the upcoming chapter's content. During the G and H points, we are going to mathematically describe the inverse Clarke and Park transformations, where the main goal is the same as with the direct transformations. We would like to deduct scalar equations that could be directly programmed in Simulink as part of the FOC algorithm. After understanding the Clarke-Park and inverse Clarke-Park coordinate transformations, we are going to dive ourselves in the so-called SVPWM, or space vector pulse width modulation technique, which is quite similar to the conventional PWM algorithm in its basic behavior, yet offers better utilization of the available voltage in the system for a more efficient drive control. Until this point, we are going to cover all the necessary information for the field-oriented control regarding the software point of view. So, we shall understand the basic concept of the three-phase voltage inverters and their possible working states, properties, and so on. During the J point, we are going to investigate the possible effects to the three-phase voltage inverters to the developed software. And finally, in the K point, we are going to introduce the most used practical encoder types and their signal processing logics regarding the software point of view.